Okay, welcome back. So just a quick little summary and review of all the Riemann sums. I feel like we've been spending so much time on this because of just the disjointedness of the days. But remember that a Riemann sum is just nothing more than an approximation of an integral, because now we know that these sums are actually integrals, by some sort of finite sum, and we usually use rectangles. There are 4 Riemann sums that you need to be able to calculate. You need to be able to do a left approximation. You have to be able to calculate a right approximation. You need to be able to calculate a midpoint. And I can't spell. My whiteout is my friend. Midpoint approximation. And we have not looked at this one yet, a trapezoidal sum. This requires us to actually know what the area formula is for a trapezoid and such. So I'm going to just kind of draw the trapezoid kind of like this. So imagine it's going to fit an area under a curve a little better actually than just using rectangles. So a trapezoid, its area is 1/2 the height times base 1, the sum of base 1 and base 2. In regards to what it would look like on a graph, this right here would still be my width, but this time it's going to be the height of your trapezoid. And these values, the B1s and B2, or for our purposes, f of B2 represents that value as essentially our sum of our bases. Okay, so we're going to take just a simplistic, again, one last kind of example with this idea, and then we're going to see what it kind of looks like in regards to tables, because tables are going to be what you see more on the AP exam rather than anything else. So let's take the example f of x equals the square root of x. We're going to look at the interval from 1 to 9. And let's do n equals 8. So we're going to use 8 subintervals, is what they're going to be called, to do our approximations. If we do these left, the right, and the midpoints, these are all just using rectangles. Okay. So let's break it down. Again, first we have to have our delta x, which is that b minus a over n. Here's my a, here's my b, my lower end, my upper end, 9 minus 1 over 8. So our width of each rectangle is going to be 1. Simple enough. My intervals, I always draw my intervals. I encourage all of you to draw your intervals and write them out. It makes life so much easier when you're doing Riemann sums. My first rectangle goes from 1 to 2. And again, this just came from endpoint plus your width. Next rectangle goes from 2 to 3, from 3 to 4, 4 to 5, 5 to 6, 6 to 7, oops, and 7 to 8. And there are your 8 rectangles and your 8 intervals. So to find my very first one, my left endpoint approximation, all I'm going to do is find the area of this region. I know I'm multiplying each length times or width times height. I know that this is 1. I'm going to put them on the outside. I don't need to multiply every single thing by 1. To find my heights, I'm just going to evaluate each left endpoint is going to get substituted into f of x to give me my values. So I get the square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, and square root of 7. 1, 2, 3, 4, 5, 6, 7. What did I miss? 1, 2, 3, 4, 5, 6, 7. Did I miss a rectangle? Dang it, I've missed one. I should have counted. I needed 8 and 9. knew something didn't seem quite right. And we extend him off. Yay again for whiteout. Plus the square root of 8. So into my calculator I go to plug those values in. I already have them ready to go in my calculator. Hit enter. Already multiplied by 1. So my left end approximation of this region underneath the curve and between that curve and the x-axis, I get this value. So we just repeat the process if I want to do the right endpoint approximation. So now I'm going to use the right endpoint of each one of these regions. So again, there's my constant width. And now it's going to be square root of 2, square root of 3, square root of 4, 5, 6, 7, 8, and 9. Okay. That goes all into the calculator. I'll spare you the anticipation. That's going to get me 18.306. Now, if you'll notice, we have this first approximation happens to be an underestimate. This right endpoint approximation happens to be an overestimate. Our actual area lies somewhere in between those two. But one of the things you're going to have to be able to do on the AP exam is be able to determine whether this is an under or an over without actually doing the math itself. And that goes back to these particular function itself. So off to the side, we're going to look at this function, and I see that we've got the square root of x. I don't need to know much about the square root functions. I just know a square root function kind of looks like this. In our region that we're looking at, or the interval between 1 and 9, what I have to note is that the function itself is increasing. Okay, so if my function